Welcome to another Netgate Tensor Tech Tip. But first, let's have a quick overview of Tensor. Tensor is a high-performance software router that can run on Netgate systems or in the cloud on AWS and Azure. It achieves speeds and performance that would otherwise be reserved for ASIC-based hardware routers, but at a fraction of the cost. Today, we will focus on using Tensor to protect your customers during an attack. Netgate introduced Unicast Reverse Path Forwarding, also known as uRPF, in version 25.02, and this is a very simple way of filtering bogus traffic. In this use case, we will assume that you are providing internet services to your customers. Here we have a very simple network, with Tensor acting as the edge router and a layer 3 switch serving your customer LAN. Traffic flows into and out of your LAN like normal, and all customers are happy. All of a sudden, one of your customers comes under attack from the internet. What can you do? You could try to filter the attack traffic at the edge router using access lists. But this router tends to be busy, and constantly editing your access lists could pose quite the challenge. You could try to filter on the layer 3 switch, but those tend to be underpowered for this application. Clearly, a more elegant solution is required. In this case, we will use another Tensor router as a filter router. Normal traffic will still take the original clean path into and out of the customer LAN. But in the event of an attack, the edge router can use ACL-based forwarding to shunt traffic destined for your attack victim across the filter path to the Tensor, acting as the filter router. uRPF is enabled on the filter router's ingress interface. A route server speaks BGP with the filter router, advertising only the prefixes that are authorized to reach the attack victim. This could be prefixes from a geo IP list or other known clean source IPs that are not involved in the attack. As traffic enters the filter router, a uRPF check is performed. If the traffic flow's source IP prefix is not found in the filter router's routing table, the traffic will be silently dropped. If the prefix for the traffic flow's source IP is found in the filter router's routing table, it will be forwarded to the layer 3 switch as normal. Of course, return traffic from the attack victim will take the clean path back out to the internet like normal. Configuration of the solution is quite simple. On the edge router, all we need to do is to configure the interfaces, of which there are 3. The first interface is going to the internet, and the second interface is going to what we are calling the clean path that connects to the layer 3 switch. The third interface is going to what we are calling the filter path, which connects to the filter router. The edge router will require a static route that routes the customer networks down to the layer 3 switch along the clean path. And in this case, we will assume that we have a customer under attack. And so we will need to create an ACL-based forwarding rule for that attack victim's IP address. In this particular case, we will assume that our attack victim is 198.51.110. As you can see here, anything matching that destination IP address of our attack victim will be shunted towards the filter router on the filter path. On the filter router, configuration is equally simple. Again, we will configure our 3 interfaces. The first one is pointing towards the edge router. The second interface is pointing towards the layer 3 switch. And the third interface is connected to a route server, which will use BGP to advertise prefixes to the filter router. The filter router will also require a static route that forwards the customer networks down to the layer 3 switch. Finally, the filter router must have a simple iBGP session configured with the route server, which in this case is 172.16.10.2. This is the session that the route server will advertise to the filter router, containing the authorized prefixes that we want to be allowed to reach our attack victim. This list of prefixes may change with any frequency necessary. The final part of the configuration is configuring Unicast Reverse Path Forwarding in loose mode on the ingress interface of the filter router. Traffic destined to the attack victim will not be forwarded unless the prefix for that traffic source IP is found in the filter router's routing table. If that prefix is not found, the traffic will be silently dropped. Because of its extreme high performance, Tensor is the perfect router for the solution. Let Netgate show you how Tensor can revolutionize your networks.